Hello, juniors. I hope you had a nice Easter break, and I hope that these days are great for you. Today, we're gonna continue with quadratic functions, which is the topic that we last covered. We've seen the different types of transformation of functions. Remember, there were three main types of transformations, which are translations, which could be either vertical or horizontal translations. We've seen reflections, which could be reflection on the x-axis and reflection on the y-axis. And finally, we've seen stretches, in which stretches or compressions, which could be either stretch horizontally or vertically. Okay, so those were all the different types of transformation we've seen. Then we started covering quadratic functions. We've seen the basics of quadratic functions and how the different types of transformations apply to this specific function. That, if you remember, the shape of a quadratic function is a parabola. Okay, so for today, we're going to see electronic assignment number 18, which is forms of quadratic functions. The objectives for this class are, we have quite a few here. The first one, understand the terms of the quadratic function, its graph, y-intercept, x-intercept, axis of symmetry, and vertex, which we're gonna see a quick review in a second about what that is about. Then write quadratic equations in the general form, f of x equals ax squared plus bx plus c. Find the y-intercept, which has coordinates 0, c, and find the axis of symmetry by applying the formula x equals negative b over 2a. Then, objective number 3, write quadratic equations in the factored form, f of x equals a times x minus p times x minus q. Find the x-intercepts po and q0. Sorry, p0 and q0. Finally, write the quadratic equation in the vertex form, f of x equals a times x minus h squared plus k. Identify the vertex h and k. So you see that these are all different types of expressing, or different forms of expressing the quadratic function. And we're going to see when it is convenient to apply each, depending on what we want to find about the parabola. Okay, so if you remember from previous classes, we've seen, let me see if I can find it here. Nope. In this class, we've seen the most important things that we should always identify in a parabola, which are basically the y-intercept, the x-intercepts, which may be 2, it could have 2, 1, or 0. We're going to see that later on. Then the vertex of the parabola, which is the minimum or maximum point. And finally, the axis of symmetry, which is the vertical line that divides the parabola in two same parts. It's like a mirror that we have over there. And then we've seen what is the condition for the parabola to open upward or to open downward. Remember that parabola opens upward if the value of a, the coefficient in front of the x squared value, is positive, and it will open downward if it's negative. Okay, so going back, we're gonna start by using some GDC, using technology. So if you have your calculators with you, I encourage you to try to practice this following what I will be explaining. So it says, transferring a graph from GDC to paper. You may be asked to sketch on a paper the graph of a quadratic function. You could do this by plotting the graph of your GDC and then carefully recreating a sketch of the graph on paper. When you sketch, and here we're defining the term sketch. When you sketch a parabola, your sketch should show the general shape of the graph accurately and label the key features, including the coordinates of the x-intercepts, the coordinate of the vertex, and the equation of the axis of symmetry. Remember that the term sketch means that you should not do a perfect graph, but you should do something that will not take you too much time to do, but that reflects the main characteristics of the graph. Okay, if you if you have the word draw or graph, then you should do a more precise drawing of the function. But in this case, when we have the word sketch, you should only do a sketch, as the name says, something quick in which you identify the main characteristics of the function, in this case parabola. So I'm going to show you how to sketch this particular example. It says the quadratic function f of x equals negative 0.5x squared plus 7.5x minus 18 is said to be in general form. You see that? Remember that the general form is written this way: f of x equals ax squared plus bx plus c. We're gonna see this also in the class today. So use technology to plot the graph f of x equals negative 0.5x squared plus 7.5x minus 18, and then sketch this on paper. Your sketch should show the general correct shape of the graph. That is, if it opens upward or downward, then we should identify the vertex and the x and y intercepts and the axis of symmetry. Remember, these are the three main things that we should show: x and y intercepts, the vertex, and the axis of symmetry. So, and then it says also state the domain and range of this function. So let's see how to do this. The first thing we should do if we want to do a sketch is we need to be able to identify how this function looks like, right? So what we're gonna do is we're gonna go to the calculator. Let me do this here. We're going to the calculator. We're in the main menu, but we want to go to menu graph. Okay, menu graph. In here, I'm gonna delete this. We're gonna plot in the function, right? The function for our exercise is negative 0.5x squared. X squared plus 7.5x minus 1. That's the equation we're given. So we plot on execute, and then we click on draw, which is F6. You see that initially we don't get the whole function. That means that our scale is wrong. One way to determine the correct scale is by going to menu table. Before going to menu graph, we go to menu table, which is menu 7. And in here, before clicking on table, we're gonna click on set. That's F5. And we're gonna give this table a range of values of x for us to be able to observe between which values the parabola is going, right? So we can, for example, put here, I don't know, negative 5 to, let's say, 10, and step of 1, that's okay. Or maybe from negative 10 to 10 would be better, right? So then you click on table, which is F6, and here you can see that the different values that the parabola is taking. You see that this is going down. You see that the coefficient in front of the x squared is a negative value. That means that the parabola should open downward, right? But if we observe the values, we would see that the maximum value is, this keeps on growing, here. Between 7 and 8 we have the maximum value, which will be around 28, 29 maybe. So we know that for y, the maximum value should be around 30, what we should put in the graph. Okay, and the minimum value, this will continue going until infinity, because the parabola keeps on going until infinity in this case. So we can set a minimum value which we prefer, which I would say we could use negative 20 as well, right? So let's go back to the problem. We go back to menu, graph. Just want to see if I wrote this equation correctly. Negative 0.5 plus 7.5 minus 1. Minus 18 is a problem, right? Yes, minus 18, sorry. So if I go back here, this should be minus 18. So this doesn't change much. This is just a vertical displacement 18 units down, but we should get the same shape of the parabola. Okay, so now if we go to draw, we're having the same problem, right? So in order to change the scale, remember it's shift Vwin, that's F3, and here you can define your scale. So we're gonna use as scale for the x. We're gonna put we could put -5. For a maximum value, we could put, let me see, we could put 20 or 10, maybe 20 will be fine. Scale 1. Then as a y minimum, we could put this -20, and as a maximum 15, for example. So here you will be able to see, if we go to exit and then draw again, here you can see the parabola correctly, right? So this is how your sketch should look like. Now, remember there are some things we need to identify from this graph in order to be able to sketch. The first thing is to identify the y-intercept, this number over here. It's where the graph crosses the y-axis, right? So how do we do that using a calculator? You go to Shift, and here you have different options, and we're gonna use this one, Gsolve, which is F5. So Gsolve, and since we want to find the y-intercept, we're gonna click on y-intercept, right, which is F4. If you click on that, you get this number, which is 0 and -18. So that's our y-intercept, okay? I'm going to write this down in the electronic assignment in a second, okay? So this is a y-intercept, 0, -18. So we have already identified that number. Then the second thing we need to identify in order to do our sketch is, or are, the x-intercepts. In this case, there are two x-intercepts, here and here. So how do we calculate that? Again, Shift, Gsolve, and instead of y-intercept, we're going to click on root. Root is a synonym for x-intercept, or solutions as well. So we could click on F1, and you see that we get one value here, which is 30. And if you click on the arrow, this one, you click it, and you get the other one, which is 12 and 0. Okay? So the x-intercepts are 30, 12, 0. That's how you get the x-intercept. Then the other thing we need to identify in order to graph is our vertex. Okay? How do we calculate the vertex? Once again, Shift, Gsolve. Since this parabola opens downward, this means that the vertex corresponds to a maximum point. Okay? So here in our options, we need to click on maximum. If the parabola opened the other way around, upward, then we would look for the minimum point. But in this case, we're going to click on max because it's a maximum point, F2. And there you have, this is the maximum point, which corresponds to x equals 7.5 and y is 10.125. Okay? Finally, the axis of symmetry corresponds to the vertical line over here, which has equation x equals 7.5. So those are all the different characteristics we should identify in our parabola. Okay, so going back to the problem. I will write down all of those characteristics. The y-intercept, first of all, according to our calculator, had coordinates 0, 18, -18, sorry, -18, right? Then we had two x-intercepts. So x-intercepts are, the first one was 3, 0, and the second one was 12,0. Then we identified the vertex. In this case, the vertex, let me see, dissolve maximum. The vertex had coordinates 7.5, 10.125. And finally, the axis of symmetry was x equals, remember you should always write x equals 7.5 because this is the correct equation of a vertical line, okay? So we have identified all the main characteristics for us to sketch. So you see how, now you're gonna see how simple it is to sketch. To sketch, I don't even need to write all the numbers in the coordinate plane. I should just do something like this. Let me see. This is x, this is y. Then the y-intercept is 0, -18. So I can just approximate this and say that, let me take this a little bit down. I can just say that this, for example, is -18. I don't need to do the scale when we're doing a sketch. I could then say that this, for example, is 0.3 and this is a 0.12. I'm identifying this. Then the vertex is at 7.5. 7.5 is always midpoint between 3 and 12, or between those two x coordinates, x intercepts, sorry. So 7.5 would be maybe somewhere around here, 7.5, and 10.125, which corresponds to the y coordinate of the vertex, I could say it's somewhere around here, 10.125. Remember, this does not need to be precise, it just needs to have the shape of the parabola we are sketching, right? So this is a vertex, this is one of the roots or x-intercepts, this is the second root, and finally this is the third root. Okay, sorry, not root, the y-intercept, sorry. Then we have the axis of symmetry, which remember is a vertical line. So I can trace this here. Let me see if it does it. There you go. No. I'll have to move this a little bit. There. So you have the axis of symmetry. And we can draw, now that we have all of the main points, we can draw by hand our parabola, which will look something like this. Up to there. If you want, you can extend this a little bit here in order to make it symmetrical with the other side, but it's not necessary. You could just leave it as it was. So this is our quick sketch of the parabola. You see that it opens downward, which is okay because the coefficient in front of the x squared is a negative number, so that's fine. Then it says, in exam hint, in examination questions where domain is restricted to a given function, you must not sketch positions or points outside that domain. That is, in case you're given that this graph is, this parabola is only graphed for the domain, I don't know, -5 to 10, you should only graph the parabola for this domain and not for the entire domain, which is all real numbers, right? That's the only thing it's clarifying there. So we're missing one last part, which says state the domain and range of this function. By observing at this function, we could see that the domain, first of all, the domain is all real numbers, right? The x value goes from -infinity to +infinity, because remember, this keeps on going downward and this keeps on going downward as well. So the domain is x belong to all real numbers. That's the same as saying from -infinity to +infinity, right? And what about the range? In the case of a parabola, in this case that it opens downward, remember that the range is from this maximum value we have here down to infinity, right? This keeps on going downward. So the range would be, we could say it in two ways. The first one is y is less or equal than 10.125, or we could say bracket, parenthesis, negative infinity to 10.125 bracket. Okay, these are the two ways of identifying domain and range. So this is our answer. Okay, so I hope you could understand this. In case you didn't understand the explanation I showed you using the calculator, here you have all of the instructions. This is the same thing I just showed you. It explains step by step what you should do, okay? So you can read this by your own. It has, I think, 12 steps. So you can follow this through in case you need to. Here are all the commands I already explained. Yes, 12 steps, and then you have the sketch of the parabola. Domain, all real numbers. Range, y less than 10.125, which is the same we wrote up there. Okay, so I hope this is clear. Next, we're gonna keep on moving with the most important part of this class, which is the different forms of expressing a quadratic function. There are three main ways of expressing a quadratic function. The first one is the vertex form, which looks like this. The second form is a general form, which looks like this, which is the same case we saw in the previous example. And finally, the factorized form, which looks this way. We're going to see each of these forms, and we're going to understand what all of the different letters mean, okay? ABC, AHK, APQ, we're going to see all of that. What do each represent, and how are all of these forms of expressing a quadratic function useful for us? Okay, so let's start with the vertex form. F of x equals a times x minus h squared plus k. So we're going to do a short investigation in order to see what happens here. So it says, graph each function by transforming the graph y equals x squared. So the first thing you want to do, if you want to do this in your calculators, you can do so. We're going to graph these three functions and also the function y equals x squared, which is the parabola, the parent function, right? The parent function of a parabola. So to save some time, I already did this sketch, which is here, but I'm going to go to the Desmos in order to be able to change some things. So here we have, first of all, the parent function, which is the normal parabola, which has vertex at 0, 0, and it opens upward. Then we have the first function that we were asked to plot. And what do you see here? If we compare this with the parent function, first of all, we can see that there is the vertex is displaced 1 unit to the left and 4 units down, right? 1 unit to the left and 4 units down. And you see that the parabola is a little bit narrower than the original red one. That is because of the multiplier we have in front of the parenthesis, which is a 2. Okay, we're going to see this in detail in a second. So that's what we can see from the first graph. If I graph the second one, this one, the green one, what do you see? First of all, let's see the vertex. Let's compare the vertex. You see that the new vertex, the green one, is displaced 2 units to the right and 5 units upward, right? And then we see that the parabola is reflected on the x-axis, right? That's why it looks the other way around. And that is caused by the negative number we have in front, which is a negative 1/2. And the 1/2 itself, what it is doing is it is stretching the parabola, right? You see that it looks wider than the original red one, right? That's because it has a scale factor of 1/2, which makes the parabola look wider. Finally, if we plot the last case, this one, Once again, you see that if we compare the vertex is displaced 1 unit to the right and 6 units down. And the -3 in front makes two things. The first one, a reflection on the x-axis, and the second, it makes the parabola look thinner, in this case, narrower, right? So, let's go back to our electronic assignment. So here we have a summary of what we just saw. This is a screenshot of the problem we just did. So by observing this, we're gonna complete the next table. It says, copy the table and record the parameters A, H, and K. Remember that the vertex form is like this, right? So here we have. Use your graph from question 1 to determine whether the graph is concave up or down, the equation of the axis of symmetry, and the coordinates of the vertex. So for the first equation, f of x equals 2x plus 1 squared minus 4. What is the value of a if we compare it with this function, which is a vertex form? The value of a is 2, right? 2. Then, what is the value of h? In this case, the value of h should actually be -1 because there's a negative sign here. So the value of h is -1. And the value of k is -4. -4. Then, is this parabola, the first one, which in our case is the blue one, is it opening upward or downward? It opens up, right? It's a happy face. Finally, what is the axis of symmetry? If we look at this graph, we see that the axis of symmetry is right here, which is the point, which is the equation x equals -1. So we're going to write here x equals -1. And the vertex has coordinates, if you see here, this is -1 and this is -4, right? So the vertex has coordinates -1, -4. Okay. I hope you start seeing a pattern with this. Let's complete the table and then we're going to analyze this. For the second function, -1/2 x minus 2 squared plus 5. The value of a in this case is -1/2, right? This is the value of a here. Then the value of h, in this case it's 2, +2. And the value of k is +5. Then, if we look at the graph, second function is the green one. Does it opens downward, right? So this is down. The axis of symmetry would be here at this point, which is x equals 2, right? Yes, x equals 2. So this is x equals 2. And finally, the vertex is at point 2, 5. 2, 5. So the vertex 2, 5. Finally, for the last case, if we look at the graph, if we look at the function, the value of a is -3. So this is -3. The value of h would be 1. And the value of k is -6. If we look at the graph, this parabola opens, it's the purple one, so it opens down, right? So we're going to write down. What is the axis of symmetry? The axis of symmetry is this line over here, which is x equals +1. X equals +1. And the vertex has coordinates +1 and -6. So this would be 1, -6. Okay, so let's keep on doing the investigation in order to analyze what we've got here. It says, look for patterns in your table and answer the following questions. Which parameter in the function f of x equals a times x minus h squared plus k determines whether the graph of the function is concave up or concave down? Which one is telling us that? You see that is told by the parameter a. If a is positive, then this move, the parabola is up, right? It's up. Yes, it opens upward. But if A is negative, the parabola opens downward. Negative, down. So positive up, negative down. That's for the A value. So if we write an answer here, the parameter A. And here we could write, let me take this from the previous class. We already did this. If A is positive, then it's a happy face. Here. There we go. If A is positive, then it opens upward, and if A is negative, it opens downward. There. Nope. Okay, there you go. Then number 4, it says, what is the equation of the axis of symmetry, and what are the coordinates of the vertex? You see that the equation of the axis of symmetry, this column over here, always matches. You see this number, this number, this number matches with this number over here. Positive 1, sorry, this should be negative 1 because there's a negative sign here in front. So negative 1, then this is positive 2. We don't see this sign over here because this sign is part of this formula over here. And the last one is positive 1, okay? So you see that the axis of symmetry corresponds to that value of h, which is inside of the parentheses alongside with the x, right? So the axis of symmetry is a value of h, so we can write that here. The axis of symmetry is the value of h. So it's always x equals to h, whatever the value of h is in the equation. Okay, and finally for number 5, it says consider the function f of x equals 4x minus 3 squared plus 2 without using your GDC. Say whether the graph is concave up or concave down. So first of all, is this one concave up or down? It's concave up because this value is positive. So concave up because the value 4 is positive. Which, remember the value 4, it corresponds to A is positive. Then it says, write down the equation of the axis of symmetry. What will be the axis of symmetry? The axis of symmetry corresponds to this value over here. So in this case, it's positive 3. Remember, the negative is part of the formula. So the axis of symmetry is x equals positive 3. That's a vertical line. Okay, so we have the axis of symmetry and the coordinates of the vertex. So finally, the coordinate of the vertex, that's a very important thing which you should always identify from this. You see that the vertex always corresponds to these two values over here. This is the x coordinate of the vertex, this is the y coordinate of the vertex, -1 and -4. X coordinate of the vertex, positive 2, y coordinate of the vertex, positive 5, right? X coordinate of the vertex, positive 1, y coordinate of the vertex, -6, okay? Remember, you can always identify that directly from the vertex form. So in this case, the vertex of the parabola will have coordinates positive 3 and positive 2. So vertex has coordinates 3, 2. Then graph the equation on your GDC to verify your answer. Okay, you can try that. You can do that on your own in order to check. I'm going to show you this quickly here. Go to your calculator, go back, we're gonna plug in the equation. The equation was 4 parentheses x what were the coordinates? I remember. Minus 3 squared plus 2. Okay. X minus 3 squared plus 2. If you draw this, it's f6. You see that? Could zoom in here. If we change the... No, okay, we're gonna leave it like this. If we solve this, you see that first of all it opens upward, which is our first answer. Second, if we calculate the vertex, remember shift G solve. In this case, we're gonna click on minimum because this is a minimum point, so min. And you see that we get 3 and 2, which are the coordinates of the vertex we identified. And the axis of symmetry is x equals 3, right? It always matches with the x coordinate of the vertex. That's exactly what we wrote here, okay? Axis of symmetry is x equals 3, and the vertex is 3, 2. Okay, then this is a summary of what we just studied. It says a quadratic function written in the form f of x equals ax minus h squared plus k, where a is different from 0, is said to be in vertex form. The coordinates of the vertex are h, k, and the equation of the axis of symmetry is x equals h. This is just what we demonstrated by doing all of this investigation. Okay, so this is the most important thing you should always remember. This is the vertex form of the quadratic equation and the different parameters that you should know what each of them represent, okay? So we're gonna do a short example and then we're done for today's class. It says, write down the coordinates of the vertex and the equation of the axis of symmetry for each function. So if you understood this clearly, you should now know that in the vertex form of a parabola, it looks like this. F of x equals a times x minus h squared plus k, where we could directly identify the coordinates of the vertex of the parabola and therefore the axis of symmetry. So for part A, if we want to find the coordinates of the vertex, we just need to look at this term over here and this term over here. So the vertex in this case will have coordinates. What coordinates do you think this will have? It'll be positive 4. Remember that this negative in the formula determines the sign of the inner value, which in this case is positive 4. So 4, comma, and then k represents the y coordinate, which is this one over here. So the vertex has coordinates 4 and 1. That means that the axis of symmetry would have equation x equals 4. Remember to always write x equals 4 or x equals something for the axis of symmetry. It's not correct for you to just write 4, okay? Because this has to be the equation of a vertical line. Okay, that's it for part A. That's the vertex and the equation of the axis of symmetry. Finally, for part B, it says 2 times x plus 3 squared minus 6. So the vertex, if you follow the pattern, in this case, the vertex would be negative 3, and negative 6. Negative 6. So the axis of symmetry would be always the x coordinate of the vertex, x equals negative 3. And that's it. So next class, that's tomorrow, we're going to see the second form, which is the general form. We're going to do the same thing. We're going to do an investigation about this, and then we're going to generalize, explaining what each of the parameters represent. Okay, so I hope this is clear for you. people. If you have any doubts, remember you can always ask in the Google Classroom and we can organize live sessions to clear these doubts. See you.